Alright, this is going to be Statics Exam 1 review for Engineering 2301. This will be covering over chapters 2 and chapters 3. Today I'm going to be doing a two-part, actually probably three-part series, going over two problems of chapter 2, another set of two problems from chapter 2, and then two problems from chapter 3. Which you see right here on your screen as I'm going to go over first. Problems are going to be 2.36, 2.37, 2.102, 2.104, 3.3, and 3.108. Go ahead and look up in your book ahead of time. I'm going to be going through these kind of quick. I'm not going to display the question or nothing. I'm just going to go right into the solution off of the free body diagram, so feel free to pause the video, go to your book, look at my free body diagram, draw it yourself, and then resume the video to catch back up what we're going to be doing. Alright, I will, however, read off the question statement. That way we can at least kind of have a audible response to it, or you'll be able to hear it. So we're going to start off with problem 2.36. Problem 2.36 states, knowing that the tension in cable BC is 725 newtons, determine the resultant of the three forces exerted at point B of beam AB. So after knowing that, we will write down our given, find, free body diagram, and our solution. So we know our given, which is 725 newtons in tension BC, and we know our length given to us by the picture in the problem, which is length BC of 1,160 millimeters. They're asking us to find the resultant and the theta angle that the resultant is going to be going at. So this is the point where you'll be looking at the free body diagram. Feel free to pause the video so you can write it down and then catch back up to us once we are going. Otherwise, we're going to jump right into it. So to start her off, we're going to go with finding the tension in cable BC. In the X and Y component. Just doing it in sum of forces is probably not going to be the easiest. You're going to want to do it in component form. So we will just start off labeling this as tension BC. We will state the sum of the forces in the X direction are going to be equal to 0, because this is a static, so everything's going to be in equilibrium. That means it has to be equal to 0. So f of x will equal a negative 725 newtons, because it is looking to the left of B. Keep in mind that point B right here is our point of interest. Therefore, our axis, if we look at it, this is our normal x and y coordinate plane, x being positive to the right and y being positive up. Therefore, tension BC will be negative. And then we need to break it into component form. That way we can get the actual force, even though we know the force, but we don't know its force in this component. So we will take its opposing direction, which will be 840 millimeters, divided by 1,160 millimeters. Note that the millimeters will cancel out, and we'll be left with just newtons. This force in the x direction will come out to negative 525 newtons. And we'll do the same thing for the sum of the forces in the y direction, equal to 0. F of y is going to equal a positive 725 newtons. Also using the same dimensions, 840 millimeters over 1160. This will come out to 500 newtons. Alright, so now tension BC is completed and we're done with it. We can go on to the next one, which will be the 500 Newton force, this force right here. You can kind of see a little better. So I'm just going to label it 500 Newton force, so I know what I'm talking about. Double arrow. Break it again into x and y components. I'm going to skip the sum of forces section. I'm just going to go straight into it. It will be negative 500 newtons in the x direction. And note that, I will zoom in just so you can see this, it gives it to us that this is a 3, 4, 5 triangle. With that being said, we do not have to find this little portion um, here for alpha. We don't need to find alpha because they give us as a 3, 4, 5 triangle. So we can just simply put it right in. So it's 3 over 5, opposite over adjacent. Sorry, opposite over tangent. This will be negative 300 newtons. Do the same thing for the y. It is also negative 500 newtons. This one is now 4 over 5, which will be opposite over tangent. So the other one was adjacent over tangent. So that was actually cosine. I'm sorry. This will come out to negative 400 newtons. So now that one's done. All we have remaining is the 780 newtons. Go ahead and we'll finish that one out. 780 newton force, double arrow. We'll start at the x direction. We get a positive 780 newtons because it's to the right of B. That is the positive x direction. Now note on this one, it is a 5, 12, 13 triangle. Same thing as before, we don't need to find that beta angle. We can just simply throw it in as we see it. So this one will be 12 over 13. This comes out to 720 newtons. Again, at any point in time you feel like I'm going too fast, feel free to pause the video, catch up, and resume in. In the y direction, we're going to have a negative 780 newtons because it's down from point B, negative, times 5 over 13. This will come out to a negative 300 newtons. So now we have all of our forces that are being applied at point B. All we need to do now is find our total resultant in the x direction, which all you do is you just add up or take the sum of all the x. All you do is just add them up. I'm not going to write it out. This will come out to negative 105 newtons. Again, you can pause and double check all that. Now for our resultant in the y, we'll do the exact same thing. We'll do the sum of the forces in the y direction. This will come out to a negative 200 newtons. To find your total resultant of the entire system, I'm going to label it as RT, which is also equal to R. Is going to be the sum of squares of the r and y. So it would be rx squared plus ry squared. And I'm going to kind of touch this up a little bit so I can actually conserve my spacing, which this equals to negative 105 squared plus negative 200 squared. We get our total resultant to come out to 225.89 newtons. Now, most likely, Dr. Jackson will also ask in the test to find the angle that the resultant is being applied at. All you have to do is state that tangent alpha is equal to your y over x dimension, which is going to be equal to your ry over rx. To find alpha, you just take the inverse tangent of that same thing, ry over rx. Therefore, alpha equals inverse tangent of 200 over 105. Notice that I dropped my negatives because this is just an angle. The signs really won't matter at this point because it's basically taking a magnitude. Therefore, alpha will come out to 62.3 degrees. Alright, so that will be the problem 2.36 for statics review. Please watch the next video for problem 2.37.